All right, today this is the final lesson in our polar coordinates unit. We're going to be finding roots of a complex number. And we're going to be using some of Domov's, his theorem as we go through this. 1 plus I to the 20th power. Now, let's think of another way we can write this. 1 plus I to the 20th power. We could go 1 to the right, I up. So this hypotenuse is root 2. So we could say this is root 2 cosine I sine. This should be 45 degrees. Now let's make this to the 20th power. All right, now what do? We used Domov's theorem. This is equal to square root of 2 to the 20th power, CIS 45 times 20. That's a multiplication. So root 2 to the 20th power, isn't that the same thing as 2 to the 10th power? There's a few ways that you can do that. One is to just do it kind of intuitively. The other way, because root 2 times root 2 is 2, and so you have to keep doing that 10 times. Or what you could say is square root of 2 is 2 to the 1/2. So root 2 to the 20th power is 2 to the 1/2 to the 20th, which you multiply these exponents to get 2 to the 10th. That's a little aside there. And this is equal to 900. Now, 900, if I subtract 360 from this, and subtract 360 from that, that would be like CIS 180. So I could do 2 to the 10th. Let's find 2 to the 10th. So it's 1024 CIS 180. What if I wanted to write it back in this form? Well, 180 is to the left, and it's 1024 to the left. So this distance is 1024. Well, the answer to this will just be negative 1024 plus, we could say plus 0I, or, so this is in rectangular, and this is in polar. So this should just be equal to negative 1024. So the answer to this is just negative 1024. Oop, that's not the button I wanted to push. Right back at you. All right, let's do this one. If you feel like you understand it, stop it, work through this on your own. If not, you can listen up. Here we go, 2 root 3 to the right, 2I up. Hopefully from here, since it's 2 root 3, a lot of people will be able to see that this is a 30, 60, 90 triangle, and this hypotenuse is 4. So in polar, this is 4 CIS 30. All to the 5th power. So now we apply the 5th power, and we have 4 to the 5th, CIS 30 to the 5th, or 30 times 5. Maybe I should write it first, which 4 to the 5th, I probably should know off the top of my head, but I don't. 1024 again. Great. Oh, yeah, because 2 to the 10th would be 4 to the 5th. So 1024 CIS 150. So if I want to convert that back into rectangular, so here's the answer in polar. Now if I wanted to go back to rectangular, let's just use the same graph. Let's just graph it in, say, red. So 150 is going to be over here. Of course, we have to use a different scale because this is 1,024. 150 is out there, so that means that's a 30-degree angle. And so this side would be half, which would be 512. This distance would be times the square root of 3, 512 root 3. So in rectangular, this thing would be negative 512 root 3 plus 512i. All right, try this to the negative 10. Let's see what happens here. Well, first we draw out our graph. We have root 3, negative I. So our graph now looks like this. And again, it's a 30, 60, 90. So this side would be 2. So in polar, this would be 2. This would be 30 degrees. CIS 330. Or maybe, or maybe more appropriately for this problem, we could say negative 30. Because if we take 330 to the 10th, that's going to be a much bigger number than negative 30 to the 10th. All right, from here, we apply the negative 10th power. So this is 2 to the negative 10th. CIS negative 10 times negative 30 would just be positive 300. Now, 2 to the negative 10th would be now 1 over 1,024. CIS 300. So if I want to put this back into polar, or back into rectangular, 300 would be down here. Now this distance is 1 over 1,024. This would be 60. This would be 30. So the x-axis would be half of that. So half of 1,124 would be 1 over 2,048. And then this would be 1 over 2,048 root 3. So this would be 1 over 2,048 minus 1 over 2,048. Maybe even on the top I could put root 3 over 2,048. Ooh, we need an I. Forgot about the I. Did I put the I's on? Wonderful. All right. Write a general formula to represent the set of all polar numbers in the plane for 3 CIS 30. Now, we could expand it like this, but for all, if we want to represent all of these that represent that same spot, we would have CIS 30 plus 360 K, or we could use an N, whatever. If we keep repeating or putting in a whole number for K, we will find all of the values that represent this spot. So we need that when we're now taking things to the, say, 1/2 power. So if we used a Mob's rule, this is going to be 8 to the 1/2 CIS. Now let's represent all of the values by saying 30 plus 360k, and now we're going to multiply this by 1/2. So 8 to the 1/2 is the square root of 8 CIS. If we distribute this 1/2 over the parentheses, it's going to be 15 plus 180k. The square root of 8 can simplify into root 4, root 2, which would be 2 root 2. And so we have 2 root 2, 15 plus 180k. So let's see all the values that this would represent. We would have 2 root 2, 15. No, I forgot my CIS. CIS 15. 2 root 2 CIS 195. Now if I add 180 to 195, that would just be 375, which would be the same thing as 15. So these would be the two values for this problem. Since the problem is given in CIS, I would write the answer in CIS. If the problem was given in rectangular, I would give the answer in rectangular coordinates. Let's find the cube root of 8 CIS 30. So z to the 1/3 is going to be 8 to the 1/3 CIS 1/3 30 plus 360k. 8 to the 1/3 is 2. If I go multiply over the parentheses, this is going to be 10 plus 120k. So my answers are going to be 2 CIS 10, 2 CIS 130, and 2 CIS 250. And if I add another 120, that would be 370, which is the same thing as 10. Find the cube root of I. Cube root of I would just be up 1. So what we can do is put this in polar coordinates. If I just go up 1, my modulus is 1. CIS at I, that would be 90 degrees. So if that's my z, my cube root of z is going to be 1 to the 1/3, or the cube root of 1. CIS 1/3, 90 plus 360k, which is going to be 1 CIS 30 plus 120k. Ooh, so all the possible answers for this one are going to be CIS 30, CIS 150, and CIS 270. So the cube root of I is at 30 degrees. Say this goes all the way out to 1, because that's our biggest value. At 30 degrees, 150, and 270. So these values, if I convert them to rectangular, are going to be square root of 3 plus 0.5. Well, because this distance is 1, right? So this would be square root of 3 over 2, because cosine. Because this would be 0.5. This would be 0.5 root 3, which is root 3 over 2. And this distance would be 0.5. Now to go over in this direction, I have negative 0.5 root 3, and then plus 0.5i. Negative root 3 over 2 plus 0.5i. and cosine I sine of 270 would just be at the point negative I, because it just goes down. There's no real component to that. So if we take, the interesting thing is if we take any of these to the third power, we should get back at I. Like if we take negative I to the third power, we know I to the third power is negative I. So negative I would give us a positive I. Same if we did it for these. If we took this to the third power, we should get back at I. All right, so now let's do the fifth root of 32. I'll give you guys a second to try this one. All right, the fifth root of 32. That means 32 is real and 0 i's. So that would be 32 CIS. It would be 32 to the right, so it would be CIS 0. Now, if that's Z, we want to take the fifth root. So that's saying 32 CIS 0 plus 360K, all to the fifth power, 1/5 power. So 32 to the 1/5, CIS 1/5 of 0 plus 360K. 32 to the 1/5 is going to be 2. CIS, the first one's going to just multiply to be 0. 1/5 of 360, I believe that's 72, but let's just check it with our trusty calculator. It is 72. Wonderful. All right, so now we have our answer. That's Z to the 1/5. So let's find this back into our real numbers, or our rectangulars. So it'll be 2 cosine I sine 0, 2 cosine I sine 72, 2 cosine I sine 144, 2 cosine I sine be 216, and 2 cosine I sine of 288. And then if I add 72 to that, do I get back? I'm hoping. Yep, that's good. That means I did my math right. All right, so here are all of the possible fifth roots of 32. Now, we know, in the past we've always known the fifth root of 22 is this answer. Now we know that the fifth root of 22 actually has 4 other imaginary answers. So if I had 2 CIS 72, let's say this full distance is out to 2. 72 is, if this is 60, this is 75, 72 would be there. If that distance is 2, to find out the rectangular coordinates of this, what we would have to do is actually do cosine. So 2 cosine 72. Let's just check to see this is in, yep, it's in degree mode, so this will produce a good answer. And then 2 sine 72, 1.9. So this, in rectangular coordinates, is 0.61, 1.9-ish. Close enough to 1.9. And that's 1.9i. So 0.6 plus 1.9i. If I take this to the fifth power, I will get something close to 32. I rounded those numbers so I won't get exactly 32, but it'll be an approximate. All right, now find the square roots of 4 root 3 plus 4i, and 6 root 3 plus 6i. Pause this and take a second, and then I'll just show you the work and the answers. All right. Here is the answer to this problem. And as I go down a little further, you can see that these are the two answers, 2 root 2 CIS 15 and 2 root 2 CIS 195. The next problem, if I page down a little bit, the cubed root of 12 CIS 10, cubed root CIS 130, and the cubed root of CIS 250. So this is your homework for tonight.